Hey everyone, welcome to the lecture for Ogive charts. Sometimes these are called cumulative frequency polygons, but to start our understanding of Ogive charts, we have to kind of tap back into percentiles. And I wanted to remind us of the first place that we saw percentiles, and that was when we were dealing with quartiles. So remember that quartiles break up the data into quarter chunks. So in this image here, it kind of just shows if you have your data sorted from from low to high, by the time you go from your minimum to your first quartile, you've covered 25% of the data. So Q1 is the same as the 25th percentile, which we can write as P 25. And if we go up to the median, so Q2 is the same as the median. We've then covered 50% of the data. So Q2, or the median, excuse me, is the same as the 50th percentile. Or P50. And then if we go up to from min to Q3, the third quartile, then we've covered 75% of the data. And so Q3 is the same as the 75th percentile, which we can write as P75. And percentiles just separate upper and lower portions of data. So a percentile is a value from your data set. If you're given something like the 20th percentile, P20, you're just saying, okay, I'm looking at the bottom 20% of the data from the top 80%. And what's to notice here is that 20 plus 80 equals 100. So if you're wondering, where did we get 80 from? Well, I have to be at 100% in totality. So if 20% is already accounted for on the bottom, 80% must have been at the top. Similarly, if I'm at the 72nd percentile, P72, then that's going to separate the bottom 72%. So what is the missing piece that's going to bring me up to 100? And that's going to be 28%. So again, I'm getting that from the fact that 72 plus 28 is 100. And then if I'm at the 90th percentile, that's going to separate the bottom 90% from the top 10%. And again, that's because I know I have 90 on the bottom, so I must need that extra 10 to get me up to 100. All right, so Ogive's base are going to rely on our understanding of percentiles. And an Ogive graph plots the cumulative relative frequency. So you can put this as a percent. You can put it as a decimal between 0 and 1. Those are fine. In some instances, you might see an Ogive that is just cumulative frequency. That's fine, but that's not how we're going to do it in this particular class for this term. So if you look at this chart here, on the bottom, we have battery temperature. And on the right, we have relative cumulative frequency. So what this is showing to us is that if we're looking at batteries recharging and we're keeping track of the temperature of the battery, I can look at this graph, if I could just zoom in for a second, and I can see a couple of things here. So between temperatures 84 and 86, that's going to account for 15% of all the batteries observed were between 84 and 86. It's a little bit misleading because that's the first bracket. So now let's look at 86 to 88, 86 to 88. And I look at that far right dot. I'm going to read 0.35 is the same as 35%. So this does not mean that 35% of batteries were between 86 and 88. So remember, we're looking at cumulative relative frequency here. So actually what this is saying is that 35% is 88 degrees or lower. And similarly, if I look at, say, 96, well, then I come up here, right? Because that corresponds there. So this is 90%. So this is telling me that 90% is 96 degrees or lower. Right? So I'm just reading this as cumulative relative frequency. So cumulative means everything up to that point, and relative means giving me a percent or a decimal or proportion. So if you look at the first question, what percentage of batteries were at 86 degrees or less? I go over to my chart. We already have it marked 86. So I go to 86 and I say, okay, what was the percentage here? And we saw that it was 15. So 15% of batteries were 86 degrees or less. Next question, what percentage of batteries were at 90 degrees or higher? So let's start with 90 degrees or less. So 90 degrees or less, let's see. So 90 degrees or less, let me find my 90. And okay, I hit my blue dot. And I can see that 45%. So if 45% were 90 degrees or less, then that means 55 must be 90 degrees or more. And that's because 45, that 55 gives me the leftover amount, bringing us to 100. Okay, next question, what is the median temperature? So remember in the beginning of the video, we said the median or Q2 corresponds to the 50th percentile. So what I want to look at, and I'll make some room for myself here. What I want to look at is, where is 50 on the vertical axis? So here's 0.5. So this would be 50% here. I go back to my line, hit it, and I say, where did you come from? And I do that by looking just straight down. And I'm just going to call that, it's not quite 91. 91 would be about here. So let's just call it 90.5. All right, and then we want to look at where Q1 and Q3 are. So I'm looking for the 25th percentile and the 75th percentile. So the 25th percentile, I'm just looking for 25. I see it here. So here's 25%. I go to my graph and then I look down, and this appears to be right at 87. So this is Q1. I'm going to call it 87. And then I'll do the same for 75. So here's 75%. Oops. And I take it back to my chart and I go straight down. And not quite in the center. So I don't know, let's call it 92.5. The last question is asking about the jump from 90 to 92 degrees. So I'm looking here. So this is the steepest line segment that we have. And basically, when you have a very steep line segment, that means that you're experiencing a lot of growth. So a lot of data was accounted for when we went from 90 to 92. So what you could say is that it went from 45% to 0.70. Sorry, to 70%. So that accounts for 25% increase. And that's the most increase from any one blue dot to the next. Similarly, if you had a very shallow segment, like say perhaps from 94 to 96, that's going to represent the least amount of growth. So you can see here from 94 to 96 on the chart, you're just going up. You're only increasing by 5%, right? Not very much. So you can look at the steepness of the line segments to say, where do we have the most growth or the highest frequency? Or you can look at the shallowest and say, where do we have the least amount of growth or the least amount of frequency? So lastly, I want to talk about how to draw an Ogive chart. So let me set up an axis and cue the movie magic. So on this coordinate system, we have our grades, which is in the first column. That's going to be our horizontal axis. And then we have the cumulative percent frequency or cumulative relative frequency. And this is going to be our vertical. And so what you want to do is it's already giving you cumulative frequency. So we're just going to plot the points starting at 0, 0. So the first point to plot is going to be using the right-hand side. So you're going to use this, 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 and this, and just plot it with its cumulative frequency. So when our grade is 60, I just realized I kind of spaced that silly. Start here at 0. And when our grade is 60, we'll go up to 5. So that's right here. And you want to connect it with a line. So again, I can see it's really shallow and 5% is quite small. So that makes sense. The next one is at 70, we'll be at 30. So that is here. And we can see we've got a nice big jump. So to go from 5 to 30, we had to increase by 25. All right, then at 80, we're going to be at 65. We want another line segment here. So this is another really steep line segment. So that's a 35% increase, even steeper. And then for 90, we're going to plot it at 80. So here's 80. Definitely not as sharp of an increase. And we actually only went up 15%. So it's a bit shallower. And then lastly, at 100, we're at 100. That was an increase of 20%. So hopefully I'm plotting this on the right lines. And that is how you plot an Ogive chart.